In this video, we are going to discuss scalar multiplication of matrices. It's important to realize that there are two different things that you can do with multiplication. One of them is scalar multiplication, which is what we're going to show here, and that is simply multiplying all of the elements in a matrix by some constant. So if you look at number 1, it says 4a. That means 4 times a. And so what you're actually going to do is think of distributing that 4 to each element in A. So since A is a 2 by 2 matrix and it has 4 elements, you're going to multiply each of the elements in that matrix by 4. And that's going to give you your scalar multiple times the matrix. So let's go ahead and do number 1. So 4a, 4 times A, 4 times each element of A. So this is not going to change the size of the matrix. It's just going to change the size of the numbers or the elements within the matrix. So I'm simply, again, going to multiply each one by 4. So negative 3 times 4 is negative 12. 7 times 4 is 28. 2 times 4 is 8. And 5 times 4 is 20. And that's it. So don't overcomplicate this. The scalar multiplying is just simply multiplying each element of a matrix by whatever multiple it gives you. Okay, let's look at number 2. Number 2 is negative 2 times A. This is still multiplying, right, by this constant negative 2. So negative 2 times negative 3 is positive 6. Negative 2 times 7 is negative 14. Negative 2 times 2 is negative 4. And then negative 2 times 5 is negative 10. And this probably seems very simple, and it is, but we're going to use it in a larger process later. So we just want to make sure that you can see where we're getting all of the pieces, what's happening, so that you can use it in a longer process soon. Okay, number 3 is 1/5 b. And so multiplying by a fraction like this is really the same as dividing by 5. So I'm going to multiply each element of b times 1/5. Or in other words, divide each element in b by 5. So this is still a 2 by 2 matrix, and so it's going to be 2 divided by 5, or 2/5. 15 divided by 5, or 3. Negative 1 divided by 5, so negative 1/5. And then 3 divided by 5, which is 3/5. And so that is the resulting matrix when I multiply by 1/5. All right, number 4. So before I do this last example, I just want to credit OpenStax, the college algebra book. It's where I got some of the information and possibly examples from this video. Please go by and check it out. There are good examples that you can work through, and they have the answers to the odd ones, so you can do those and check your work. So let me go back up and see what A and B are. So A is negative 3, 2, 7, 5. Okay, let's make sure that's right. Negative 3, 2, 7, 5. Yep. And then B should be 2, 15, negative 1, and 3. So I said 2, but then I put a negative. Let me erase that. Okay, so let's see again. 2, negative 1, 15, 3. Okay, so now I know my A and my B, the two matrices. So I'm just going to do what it asks me to do. So 3b So if it helps you, you can write it like this. Sometimes it's helpful if you have more than one operation going on at once. And so in this, we're actually using the idea of scalar multiplication as well as finding a difference of matrices, which we learned in a previous video. So first I'm going to do multiplication. So the scalar multiplication should come first. And so when I do that, I'm going to multiply each element within that matrix by 3. So 2 times 3 is 6. 3 times 15 is 45. 3 times -1 is -3. And 3 times 3 is 9. Okay. Then the next step is to find the difference of these two matrices. Since they are the same size, I can subtract these. And so I just subtract elements that are in the same position within its matrix. I like to change the subtract to add and then change all of the signs in the matrix following it, kind of distributing that negative, and then just add. So I have 6 plus 3 is 9. 45 plus -7, well, that would really be just like 45 minus 7. So let's see, I believe that's 38. And then -3 plus -2 is -5. And then 9 plus a -5 is 4.